Hello, this is Matz, the creator of the Ruby language. Today I'm going to talk about the Beyond Ruby 3.0. For the last several Ruby conferences, so that I talk about the future of Ruby as Ruby 3. And then finally, Ruby 3.0 was released on December 25th, 2020, so last year. So as a beginning, I'm going to summary what's new in the Ruby 3.0. The first one is static typing. Now, this is the age of static typing. The modern language like Go and Rust and Swift, all these languages are statically typed. And then our old friends, the dynamic programming language like a PHP, Python, and then JavaScript, all went to the static typing, like adding the type annotation, type hinting, or some statically typed dialect named TypeScript. So they are still dynamic, but they adapted some kind of the static type annotations or gradual typing. So now we kind of feel like everyone goes static typing. So as Ruby, what shall we do? To tell the truth, so that I don't want type declarations. I don't like that because it's kind against dry principle. So that now we have Ruby program without any type declarations. So that adding those declarations is to help compilers to work better. So that if computers or compilers are smarter, so that we don't need them, I believe. So that at the same time, we don't want the type declarations, but we want more precise checks that we couldn't do that with dynamic typing. And we want to detect error earlier, and then we want code completions, like the development experience, like developing in Java using some kind of the IDE like IntelliJ or VS Code or something like that. So that, yeah, so we kind of want static type checks, but without type declarations, so that we accomplish those things by using tools, not language enhancement. So that we added several components to Ruby 3 to enable static typing without type declarations. The first one is Ruby signatures. The second one is type prof. The third one is the third-party static type checkers like Steep and Solvit. The Ruby signatures is kind of like a TypeScript's D.TS counterpart. It's a language to describe static types of Ruby language. This is similar to Ruby, but it's focused to describe types. This is a simple example of the RBS language. And then the RBS language also supports the generic types and then interface, so that you can describe those kind of the higher order types if you want. Then the core libraries, the RBS description for the core libraries was shipped with Ruby 3.0. By using those informations, we can implement type checkers and better ID, better code completions, type signature pop-ups. The second component is the type prof. Type prof is a kind of the type checker using the technology named abstract interpretation. This is kind of like a abstract execution of the code in the basis of the type analysis. The type prof does the native type checks, and then it also generates the RBS for your applications. And then recently, Endo-san, which is one of the core developer, developed the type prof ID, which is which enables Java TypeScript like development experience using VS Code. In these conferences, we have the talk from Endo-san, who is in charge of the type prof ID, and then I believe he will introduce you type prof and the type prof IDE in detail, so that anyway we can enable those kind of static typings. We have also the VS Code State plugin, which helps the type checks using the VS Code. That by using those tools, your Ruby development experience will be improved very much. The second new changes in Ruby 3.0 is concurrency. We have added the async fiber and Raptor. Async fiber is some kind of the fiber, which is the lightweight the concurrency entity for IO heavy tasks. But it's kind of like the Node.js experiences. But instead of using the callback, it uses fiber to switch context. But for every IO operations, when every IO operation blocks, it switches context to the other idle fibers, so that we don't need the reserved keyword like async or await. It's just any IO operation can switch context. It's much easier to write and easier to handle. But now we are in the multi-core ages. How can we use multi-core for CPU-intensive tasks? We accomplish the improvement by using something named Raptor. Raptor stands for the Ruby actor. So that it's kind of like an actor model. Then that can be used for CPU-intensive tasks. The raptors are kind of isolated object spaces. But it's kind of like a separated execution body. So the object spaces are isolated each other. So each raptors can execute asynchronously. But when they need to communicate, so they can share information via the sort of channels. So as a result, so that we don't share states between reactors, so that you don't have to worry about the deadlock and rest conditions. That we don't have to worry about the global interpreter lock, which was caused by the global interpreter lock to avoid some kind of the deadlocks and the race condition in the virtual machine. Actually, reactors can share information, but those sharings are very limited, unlike threads. Only those objects can be shared between reactors. Immutable objects, for example, numbers and symbols, or the frozen strings, or something like that. And then recursively frozen objects. Frozen array for each element is frozen. And then as exception, classes and modules can be shared between reactors. And then, in Ruby, classes and modules are mutable, so that every access to class and module should be mutually exclusive between in the virtual machine, so that we have some kind of the global interpreter lock for the classes and module accesses. But except that, no global interpreter lock between reactors, so that it can use the multi-cores. That's good things. This is the very silly benchmark for reactors. The Tarai is the recursive calculation of the recursive benchmark calculation. And then the first one is the sequential execution of Tarai function for 4 times. The second one is the parallel execution. They initiate 4 reactors and then they run them. So the result is pretty interesting. Okay, real world execution. Okay, sequential version takes 64 seconds, 64.56 to 194 seconds, and the parallel version only takes 16.68 seconds. That means the Raptor version, 4 parallel version, is 3.87 times faster. That is not bad. That is not bad. In the real world example, we have the communication channel, and then we have the the Raptor communication cards and the garbage collections. The 3.87 times is the kind of the artificial benchmarks, but the numbers are promising. Now, we are now under the process of improving the performance of the reactors, so that we will see the even better number in the future. Okay. Third improvement in Ruby 3.0 is adding new syntax. The major ones are pattern matching and numbered block parameters. Pattern matching is added in 2.7. This is example of pattern matching. The JSON parse takes one JSON object and then search for the person named Alice, and whose children's search for the children named Bob. And if you find Alice who has a child named Bob, print the age of his son, her son, or otherwise print no Alice. This is much simpler on the straightforward and even declarative. That's nice. And in 3.0, we have added the one-line pattern matching. This is kind of the enhancement of pattern matching using like this. This hash rocket is the one-line pattern matching. The left-hand side is the value 1. The right-hand side, A, is a pattern. So the 1 matches the pattern A. So that this looks like a right-hand side assignment, which we abandoned in root to 7. And then this works as a assignment operator. But this pattern matching can be used like a the multi-assignment, like a foo value foo must be an array, and then takes two elements, A and B, and assignments. And then if this pattern doesn't match, it raises it as exceptions. That can be used as the JavaScript like a decomposition, like the foo value, the value corresponding to the key foo is assigned to A, and the key bar value should be assigned to B, like that. Yeah, this simple enhancement is pretty much useful and convenient. Numbered parameters. This is kind of simple. The underscore 1 can be considered as the first block parameter. And then, 1, 2, 3 dot map underscore 1 times 2 makes 2, 4, 6 or something like that. And for very simple block body, this kind of the number block parameter is pretty useful. And I don't recommend to use those numbers numbered parameters in the very complex block body. It can confuse you very easily. Anyway, successness itself is power, so that Ruby is enhanced as a language syntax to make your program more understandable and succinct, and then declarative or more intuitive. That's the very much goal of the Ruby language. The third improvement to Ruby 3.0 is performance. Language for programming languages, performance matters. That's the reason we had some kind of the slogan or goal named Ruby 3x3, which means that Ruby 3.0 should be 3 times faster than Ruby 2.0. So that we have improved many regions, domains, like memory management, and the instance variable accesses, the method calls, and many regions. And then we even added the JIT compilers. Since Ruby 2.6, we have provided the JIT compiler named NJIT, so that from those improvements, Ruby runs 3 times faster. Ruby 3.0 runs 3 times faster than Ruby 2.0 in some benchmarks, not all though. Especially after Carrot, which is the Nintendo emulator, and then it is 3.1 times faster in after Carrot benchmark or something. That's not bad. So in summary, so the Ruby 3.0 we provided the static typing and concurrency and several new syntax and improve the performance. But that's what we have. They are great. So the Ruby language are progressing, evolving. So how about the future? How about beyond Ruby 3.0? We are going to release the Ruby 3.1 in next Christmas, the December 25th this year. But what shall we, what will we have? What will we have in the next release or beyond? So our goals, our improvement are in two folds, tools and performance. Okay, Ruby is great language, I believe, and I hope you believe so too. And the Ruby user experience was from the language. It is nicely designed programming language that enhance your ability and enhance your productivity. But these days, better programming user experiences will be from tools. Like remember that the IDE things, so that in ancient times we have the text editor without any language mode, just text editor, so that we can program in those editors. But these days, editors or integrated development environment IDE is much smarter than that. So that using those tools, those IDEs or smarter editors, that our user experience has been improved a lot. And we need to have even smarter tools. Remember that Ruby static typing is supported by tools, not the language enhancement. So that in theory, the Ruby static type checks can be used in older Ruby since 2.6, I think. That is great things. That means the tools are more important today. Tools is more important than the language itself. We already have nice language, so that all we need is better tools. Yeah, no, not all, but most of our needs are in tools. So we have SolarCloud, which is the language server protocol tools. We have Solvay, which is the static type checker. We have RubyConf, which is a linter for better code. So those better tools enables better user experiences. And I think we need more tools. We need to improve the type checker, formatter, language server protocol tools, performance tuning tools, and debuggers. Recently, our RB debug gens has improved the performance and the features. And we need those kind of improvement over the tools, so that we really, really encourage community to improve those tools. Because the most of those tools are not from our core developers, but from the community. So that we need to work together with the community. The second important improvement beyond Ruby 3.0 is performance improvement. Ruby is human-oriented language. That means the performance is not the first priority. But it's far more difficult to improve the performance of the Ruby language than improving the performance of the more, design performance in mind. For example, like C, C++, or even Julia or something like that. But for Ruby, the performance is not the first priority, but still performance matters. Developers are willing to pay the price, not for cleaner languages, not simpler languages, but for faster programming languages. Remember that we have some kind of the compatibility gap between Ruby 1.8 and Ruby 1.9 in some times ago. But the community were willing to pay the price to migrate to the 1.8 to 1.9, not because 1.9 is better programming language, but because 1.9 has new virtual machine named Yarp, and which was far faster than Ruby 1.8. That was a lesson for us. Performance matters. Performance heals problems. Performance forms reputations. And we love performance comparison. And how we measure the performance. Programming language has many aspects. The programming language can be used for many purposes. That we cannot assume how they are used. Originally Ruby was a scripting language, so that simple text processing and then the programmer tools are the main target of the at the very beginning of the Ruby development in early 90s. But now Ruby are mostly used for webs, so that we cannot assume how they're used. Some may use Ruby to implement games. Many use Ruby to implement web applications. Some uses Ruby for scientific computing. Some use Ruby in text processing. And despite those many usage of how we measure performance, so that when we talk the performance of the language, how we measure the performance, actually by micro benchmarks, like calculating factorial numbers or Fibonacci numbers or word counting from the big text data or something like that. Are they related to the real world performance? I don't think so. Those kind of performance benchmarks are a fun story for idle chat. But unfortunately, people make decisions on false assumptions. If this language calculates Fibonacci numbers very quickly, if we implement the web application using that languages, probably we have the faster web applications, right? No. But well, but in fact, performance, especially the micro benchmark performance, forms reputations. In fact, Ruby is fast enough for most of the cases. For example, the GitHub, Shopify, Instacart, and Cookpad, and many other the big web services are implemented in Ruby. That means that Ruby is good enough. Of course, they have problems, and if of course they might have challenge in the performance or the cost. But they can manage Ruby to implement their services. So the performance from the reputations and the micro benchmarks from the reputations. Okay, we will improve performance. Not only for real world applications, that's important, but for micro benchmarks too. People trust benchmarks, unfortunately, so we will improve the performance on micro benchmarks. For your informations, Python seeks similar way. May this year, in the Python Language Summit conferences, the creator of the Python language, Guido van Rossum, declared they will work on the faster C Python. And then they started working on the Shannon plan. And they try to make Python 3.11 2 times faster. And then they have a lot of things to improve. So the Python tries to run 5 times faster in 4 years. That means that 50% faster each year for 4 years. That means that 1.5 powers to 4 equal 5.06 to 5. That's almost 5 times faster. And then they are going to improve the adaptive bytecode interpreter, better frame stacks, zero overhead exceptions, faster integer internal, just-in-time compilers. Some of them have already done in Ruby3.0. For example, the better integer representations, or we already have inline cache, both in the instance variables and methods, and we have better frame stacks, and we have some super operators, and we already have the JIT compilers. But I don't think current Ruby is not 5 times faster than the current Python. From that fact, I am suspicious about the Python's estimations. But I would be happy if I'd be proven wrong. They are smarter and they have much bigger budget. So that if they prove we are wrong, and we will try to improve the performance in many aspects. But I declare new goal with reverse redux. That means that Ruby 3.x will be 3 times faster than Ruby 3.0 in some benchmarks. Our improvement continues. We are going to improve the JIT compiler. Probably we are going to add some kind of lightweight JIT. The original author of the MJIT, Vladimir Makarov, provided some technology named Mill, and the Shopify teams provided YJIT. But we are now working on the integrating YJIT into Ruby 3.1. But time is limited. I'm not sure they make it or not. But YJIT will be integrated in sooner or later. So that maybe 3.1 or maybe in 3.2. but we are going to have it anyway. So that once we integrated YJet, we are going to have the multi-layer jet, which is the most of the code runs in the virtual machine in the beginning, and some hotspot will be compiled by the lightweight jet, like a YJet. Then some kind of the heavyweight jet, heavyweight hotspot will be compiled by the heavily optimized MJet or something like that. That will be improve the JIT compiler much more. As a performance, say the MJIT, the current JIT compiler makes Rails applications slightly faster, but YJIT improve the performance of the typical Rails application by 10% to 20%. So that 10% is great. 10% improvement is great. So that the number from the YJIT is pretty promising. So that we will work on those technologies to improve the performance. And we are going to implement the Raptor performance. And probably we are going to work on the NM Raptor, which is the N threads and N Raptors on M Raptors on M native threads. But currently we have the 1-to-1 correspondence to the Raptor and native threads. So that if you create the 100 Raptors, we create the 100 native threads. But on Linux systems, the one native threads consumes 4 megs of memory. That is huge. But once we implement the NM Raptors, the memory consumption will be much smaller, and then we can use Raptors more casually, and the Raptor will be more lightweight than current 1-to-1 Raptors. We are not going to see much language enhancement in the near futures. We are going to focus on the improvement of the implementations for a while. So that I am a dreamer. I wanted to design a great languages. When I started Ruby in 1993, I did not try to create the world dominant programming languages. But I just wanted to good languages, nice design, designed by myself. I can make decision on that languages. I can put anything I like to be a good languages. And then I see my dream come true. I have a great language named Ruby. And then so many people using Ruby, and then many people using Ruby happily. But I still am a dreamer. I want an even greater programming languages, which is productive and fun to use and fast. But we need you to create a future. But I still control Ruby, but I cannot control the community, and I cannot implement those tools and the features and the future by myself. But with help with the core developers and with help from the community, we can make the great things. And For example, those improvements like MJ, YJ, reactors, those improvements are not done by myself. I made decision, right? But I didn't implement it. I We as a community implemented those improvements. And then, of course, future improvement also should be done by the community and the team members. We are focusing tools on performance improvement, so that we need to encourage people and the community. So the Ruby Association, which is the organization I manage, and to help the development of the Ruby, so so that we have some kind of encouraging grant, Ruby Association grant, which is the $5,000 US dollar, and then it is described in this URL. Unfortunately, at the time of this conference, the this year's the grant proposal was closed already. I'm sorry, but we are going to have the next same grant next year, so that prepare for the next year and propose some kind of improvement plan. And uh, actually, right now we have the 3 grants per year, but we may have more number of grants if our budget allows. Then we accept the tools improvement and scientific computing, work in the scientific computing, or the MRuby improvement, or CRuby improvement, of course. Then, so that we accept those proposals to those grants next year. In addition, we are going to have some kind of the shootout improvement challenges. Shootout improvement challenge means that we will provide several benchmarks, including micro benchmarks and web application benchmarks and something, and then improve performance of these benchmarks by CRuby pull requests or by improving benchmarks. And then those submissions are evaluated according to the portability. Actually, we can the portability, manageability, and performance, and then top improvers are awarded, probably with some kind of encouraging grants. But we are still discussing, so that details regulation will be announced later from the Ruby associations. I need to discuss with other Ruby Association board members. Probably your donation can be enhanced the grant. So that Ruby associations, Japanese organizations accept the donations, and Ruby Central, of course. I'm not a board member of the Ruby Association, but I think Ruby Central accept the donations towards this grant or something like that. And actually, I'm too lazy to discuss with those board members previously, so that I'm sorry about that. But I need to take time to discuss with them and set the regulations and the programs with those grants, and so that details of the donations and the grants and the challenges will be announced later. Anyway, we will keep moving forward. This is our slogan. We will keep moving forward. We are not going to stop progressing. because we don't want to die. We will keep moving forward as we have always tried to create better world, you know, by the existence of Ruby languages. I believe was the world become better place to live for me and for programmers, for you. And then I, in in a sense, I made a better world, and probably you can do it too. Okay, thank you. This keynote and my activities are sponsored by Salesforce.com. So last year, I resigned Heroku, but the Salesforce still sponsors me. Thank you, Salesforce. And I also, my activities are also sponsored by the NSCL company in Japan, which sponsored me for last 24 years. And then I'm also sponsored by GitHub sponsors. Thank you, sponsors. And my activities suppose not my activities are also encouraged by Ruby community. So that by each member of the community, I appreciate each member of the community and each activities they make. That's all, folks. Thank you. Enjoy the rest of the conference. Bye.